Good morning. Welcome to TMMS Productions. Today we are going to see some important ICSE chemistry questions for the board examination. Do keep something to write on and solve the questions simultaneously so that you can have to give you a better understanding, pausing the video whenever required. The first type of question will be name the following. Number 1, the third member of the alkene series. Now remember, alkene is C double bond C will be there, at least one of that. And so the first one will be ethene with 2 carbons. Second one will be propene with 2 carbons. And the third one will be butene. So we will have butene. And that will be our first answer. Second member of carboxylic acids. Now first one is methanoic acid, second one becomes ethanoic acid, eth being 2 carbons. So ethanoic acid. Organic compound that decolorizes bromine water but has no reaction with ammoniacal cuprous chloride. Now decolorizes bromine water means it will be double bond or triple bond. But the one which will decolorize bromine water but will have no reaction with ammoniacal cuprous chloride. Now ammoniacal cuprous chloride is the test for ethine. So the one which will decolorize will be your ethene, because it will have double bond and yet it will not react with ammoniacal cuprous chloride. Isomer of butane with a branched chain, IUPAC name. Now butane has 4 carbons and one of the carbons will shift 1 carbon and come to the middle carbon. So it will be C single bond C single bond C with a carbon here. So it's going to be 2-methyl propane. So 2-methyl propane. That would be our answer. The gas produced by the action of dilute nitric acid on copper. Now dilute nitric acid will always give with copper water and NO, that is nitric oxide. So the gas produced will be nitric oxide. A gas other than hydrogen chloride gas which gives dense white fumes with ammonia. For this, the answer is chlorine, because with excess of ammonia, it forms ammonium chloride, which is dense white fumes. The 7th one, a chloride which is soluble in excess of ammonium hydroxide. Now here you have to remember it is silver chloride. Which forms diamine silver chloride with excess of ammonium hydroxide solution. A gas which reduces hot copper oxide to copper. This is the reducing agent. The gas which is reducing agent is ammonia. A solid drying agent that cannot be used to dry ammonia, and that will be fused calcium chloride. Now normal calcium chloride is solid, but we cannot use it to dry ammonia because it reacts with ammonia. A solution which turns aqueous copper sulfate solution to deep blue solution is going to be ammonium hydroxide. I'm just writing the formula, but for the exam you have to write the full form. There is no place here. So, an orange-red oxide which on boiling with concentrated hydrochloric acid liberates a greenish-yellow gas. Now orange-red oxide is Pb3O4, so it will be tri-lead tetroxide. and alcohol commonly present in hot drinks. Now alcohol means alcohol because it is ending in all. Now the only drinkable alcohol is ethyl alcohol because methyl alcohol is toxic in nature. A reddish non-metal which occurs in liquid state is bromine. A white alkaline powder which on heating with ammonium chloride liberates ammonia will be calcium hydroxide, because with ammonia and with this hydroxide double decomposition will take place and ammonia will be liberated. The method used to purify extracted metal using electricity is electro-refining. The electrolytic process of deposition of a superior metal on the surface of a less expensive metal is electroplating. The arrangement of element on the increasing order of the ease with which their ions will discharge is electrochemical series. Now here we have another type of question where you have been given A, B, C, D, E different methods of preparation of salts, and these are the salts which are to be prepared. So let us look at copper chloride. Now copper chloride will be action of an acid on an oxide or carbonate. So this will be your B. Iron 2 chloride, iron is an active metal, and so for iron we will have to have the metal with acid. So we have action of an acid on a metal, that is A. Iron 3 chloride is FeCl3. We have direct combination of synthesis, the method for that. Lead 2 chloride is insoluble, so it will be precipitation for that. Sodium chloride is the soluble salt where we can prepare it by titration. The next question is, from the list of substances given below, choose the pair required to prepare the salts from 1 to 3 in the laboratory and write down the relevant equations. The substances are given like so, and the first one is sodium chloride to be prepared. Then we have lead chloride and zinc chloride. So let us see how we can take sodium chloride. We need sodium, so we will take sodium. Here you have sodium hydroxide, and for chloride we will take dilute hydrochloric acid. Now why do we do that? Because sodium hydroxide will give you the base, and this will be the acid. It will be neutralization by titration. So the substances are sodium hydroxide solution and dilute hydrochloric acid, and the equation would be sodium hydroxide is NaOH plus HCl dilute will give us NaCl, that is sodium chloride that is formed, and plus this is water. Now let us look at lead chloride. Now for lead chloride, let us look at something with lead. Now we cannot take lead metal, we'll have to take lead nitrate. So lead nitrate, and for chloride we will have to take, let us see if sodium chloride is there. No, so we'll have to take dilute hydrochloric acid, and so it will be PbNO3 twice, that is lead nitrate, and dilute HCl, and that will give us PbCl2, which is lead chloride, plus it will be 2HNO3. Now this is an insoluble substance, so we will show down arrow. Let us look at zinc chloride. Now zinc chloride, zinc is an active metal, so we can look at even the metal zinc. Here it is. So we will have zinc and dilute hydrochloric acid, and so we will have Zn plus 2HCl dilute, and that will give you ZnCl2 plus H2, which is a gas. Now the third type of question that we have is, what will you observe when? So we have observations required. Now just to save on time, I will just say, and if you wish to, you can just look at the markings that I do over here, and then you can write on your own. Sodium hydroxide solution is slowly added to iron 3 chloride solution. Now iron 3 chloride will form the iron 3 hydroxide double decomposition reaction, and it will be reddish brown precipitate which will be insoluble in excess of sodium hydroxide. Concentrated nitric acid is added to copper. Now concentrated, it's going to release nitrogen dioxide, and the observation for that is dense reddish brown fumes of nitrogen dioxide are liberated and the solution turns blue because copper forms copper nitrate. Third one, concentrated hydrochloric acid is added to red lead, which is Pb3O4. Now concentrated hydrochloric acid is going to liberate chlorine, and so here observation is going to be greenish yellow chlorine gas is liberated, which turns moist blue litmus red and then bleaches it. Dilute hydrochloric acid is added to lead nitrate solution and the mixture is heated. Now lead nitrate, this cation will go with the Cl of hydrochloric acid and it will form lead chloride. Now remember, on heating, lead chloride is going to dissolve. So our observation will be chalky white precipitate of lead chloride is formed, which dissolves on heating. Dilute sulfuric acid is added to barium chloride solution. Now barium will combine with SO4 of sulfuric acid and it will form BaSO4, and that will be white precipitate which is insoluble in all mineral acids. Ethyne is treated with ammoniacal cuprous chloride solution. Now ammoniacal cuprous chloride with ethyne bubbling through it will give you red precipitate of copper acetylide. Methane is treated with bromine solution. Now bromine solution will have reddish brown color of bromine discharge with double bond and triple bond, which means ethene and ethyne, but methane is alkane, so there will be no change. Brown color of bromine will remain the same. Now let us see one more question on observation. What do you observe in the following cases? Copper is heated with Conc sulfuric acid. Now copper with sulfuric acid will give you CuSO4 and it will liberate SO2. So we will have reddish brown copper dissolves in sulfuric acid forming blue solution of copper sulfate, and colorless sulfur dioxide will be liberated, which will turn lime water milky, and acidified potassium dichromate solution from orange to clear green. Hydrogen chloride gas is passed through a solution of silver nitrate. Now silver nitrate will form silver chloride followed by excess of ammonium hydroxide. So silver chloride is going to be the curdy white precipitate which is soluble in excess of ammonium hydroxide solution. Ammonia gas is passed over heated copper oxide. It's going to reduce copper oxide. Copper oxide is black amorphous powder, and that is going to become copper metal, which will be pinkish brown metal. Ethene is passed through the solution of bromine in carbon tetrachloride. Now ethene means double bond between carbon atoms, and therefore brown color of bromine will be discharged. That's your observation. Sodium hydroxide solution is added to the solution of the cation iron 3, that is Fe3 plus, will form its hydroxide, and that will be reddish brown precipitate of FeOH twice, which will be insoluble in excess. Let us see some more observations. Now ammonia gas is burnt in air. It burns with greenish yellow flame. Hot concentrated nitric acid is poured on copper turnings. Copper is going to turn into copper nitrate, which is blue in color, and concentrated nitric acid is going to liberate reddish brown nitrogen dioxide gas. Third one, aqueous solution of copper sulfate is electrolyzed using copper electrodes. Copper electrodes are going to be active electrodes, and so observation will be blue color of copper sulfate solution will remain the same. Hot concentrated nitric acid is poured on sawdust. It bursts into flames, and the reddish brown fumes of nitrogen dioxide are liberated. Freshly prepared ferrous sulfate is added to dilute nitric acid. Then concentrated sulfuric acid is added very slowly by the side of the test tube, and then the test tube is allowed to cool. That is when we'll see a brown ring at the junction of the two liquids. Now let us come to the next question. This is the fourth type of question. Write the preparation of ethyne from calcium carbide. Now this is a very popular question. You must know this by heart. Calcium carbide is CaC2, and plus we will have 2H2O, which gives us CaOH twice, plus acetylene is C2H2. Acetaldehyde from ethane. Now ethane is C2H6, and we want to prepare acetaldehyde. Acetaldehyde is CH3CHO. Now from alkane to aldehyde there are two steps, because alkane becomes alcohol and alcohol becomes aldehyde. So we will have two nascent oxygens, and the condition is acidified K2Cr2O7 solution, and I will get a water molecule liberated. So let us come to another one here. How are the following conversions carried out? Ethene to ethane. Now ethene is C double bond C, and it has become single bond. So addition of hydrogen, and so it has become ethane, and the condition is nickel at 300 degrees C. Let us come to the next preparation. Ethene to 1,2-dichloroethane. So ethene again I will show with the structure. This is our ethene and we have to prepare 1,2-dichloro. So I am putting Cl here and Cl here. Now look at this, double bond has become single bond and chlorine has been added. So you'll write here chlorine and here the condition will be in CCl4, which is inert solvent. Ethane to bromoethane. So now we have C2H6 and it has become C2H5Br. So we have bromine added to that, and so because this is alkane which is saturated, one H has gone, so that one H will take one Br and it will become HBr. Our condition is UV light or diffused sunlight or heat. The next question of this type, prepare lead sulfate from lead carbonate. It is a two-step process. Give the necessary equations. So we are starting with lead carbonate, which is PbCO3. And in order to prepare lead sulfate, first we must make it into its nitrate. So we add 2 HNO3 molecules dilute and we will have PbNO3 twice plus H2CO3 means what? H2O plus CO2, which is a gas. This is our first step, and the second step is where we take PbCO3. Second step is where now we take this lead nitrate, PbNO3 twice, and we want sulfate, so we will take sodium sulfate solution and we will get PbSO4, which is insoluble, plus 2NaNO3 will be obtained. Write balanced chemical equations for the following. Sulfur is heated with conc nitric acid. This everyone should know by heart. S plus 6HNO3 concentrated on heating gives you H2SO4 plus 2H2O plus 6NO2, which is a gas. Zinc oxide is treated with a conc solution of sodium hydroxide. Now ZnO plus NaOH will give us Na2ZnO2 plus H2O. So Na2, that will make it 2NaOH, and that is how we'll have the balanced reaction. Third one, ammonium sulfate is heated with calcium hydroxide. Ammonium sulfate is NH4 twice SO4 plus calcium hydroxide CaOH twice, and that gives us CaSO4 plus 2NH4OH means 2H2O plus 2NH3, which is a gas. Aluminium hydroxide is heated. AlOH thrice. When it is heated to 1100 degrees C, gives Al2O3 plus H2O. So you will have 2 AlOH thrice will give us 2Al, 2Al, and it will be 3H2O. Carbon is heated with conc sulfuric acid, C plus H2SO4 concentrated will give us oxidized product, and it will give us, and the balanced reaction will be complete and balance the following: C2H5OH plus O2. Now this is oxygen, so your condition will be copper tube at 200 degrees C, and it will be alcohol becoming aldehyde. So it will be CH3CHO plus H2O. And the balanced reaction would be 2 here, 2 here, and 2 here. Another question of the same origin is, name the organic compound prepared by each of the following reactions. Now C2H4 plus Cl2. Now here there is going to be double bond between the two carbons, so it will become single bond, and this will get added over here, and it will be C2H4Cl2. And what is the name of the compound here? It will be, because the chlorine will be, I should just write it over here. Chlorine will come here and here. These are all your earlier hydrogens. And so the name of this will be 1,2-dichloroethane. CH3COONA plus NaOH. Now here you will have, and that will give us CH4 plus Na2CO3, and the name of the compound is methane. The third one, C2H5Br plus KOH, alcoholic. Now alcoholic KOH results in unsaturation. So C2H5 has a single bond. It will become C2H4, and one H will take one OH, so that will give you H2O. And this Br will go with K, and that will give us KBr. And the product is here C2H4, which is ethene. Fourth one, C2H5I plus 2H. Here we have to write boil. Now out here the condition will be ZnCu couple in alcohol, and one H will take one I and the other H will come here, so I'll get C2H6 plus HI, and the compound is C2H6 is ethane. C2H5Br plus KOH aqueous. Now aqueous will give you double decomposition like this. So it becomes, we have to write here boil, and that will give us C2H5OH, and plus K will take Br and it will become KBr. And we have this product, it is ethyl alcohol, means ethanol. C2H4 plus Br2 is exactly like this. So it will be C2H4Br2, and the condition will be UV light, diffuse sunlight, here also the same thing, UV light, diffuse sunlight. And here you will have the name again, it will be 1,2-dibromo ethane. H2S plus HNO3. Now with H2S and HNO3 dilute, we have this reaction with 3H2S and we have 2HNO3 dilute, and this gets oxidized, so we have 3 sulfur plus we will have water and we will have nitric oxide. Now you will see there is 6 and 2, 8, so 4H2O, and there are 2 N's, so that is 2NO. Next one, NH3 plus excess chlorine, so it will be 3Cl2, and that will give us NCl3 plus 3HCl, which is a gas. Ammonia plus oxygen, platinum with 800 degrees will be 4NHC plus 5O2, and that will give you 4NO plus 6H2O plus 21.5 kilocalories heat. Mg plus very dilute HNO3 cold, that is 1% dilute. Here it will be 2 HNO3 we will be taking with Mg, and we will have magnesium nitrate formed, and plus hydrogen will be liberated. Let us come to some more questions of completing the equations. Na2S2O3 plus HCl. Now here HCl is dilute and you have to take 2 HCl, and so you will have 2 Na will take 2 Cl plus H2S2O3 means H2O plus SO2 up arrow because it's a gas, and sulfur down arrow. Phosphorus plus HNO3, here it is conc HNO3, phosphorus becomes H3PO4 plus conc HNO3 gives H2O plus NO2, which is a gas. So H3PO4 plus H2O plus 5NO2. To balance that, 5 Hydrogen also is balanced, and that is our answer. Let us look at one more type of question that we get is something like this, where we have A, B, C, D, E diagrammatic representation. And so let us look at our A reaction. Nitric acid to nitric oxide, that is NO. So we will have, you can take copper or iron or even zinc. So it will be copper plus HNO3 dilute will give CuNO3 twice plus H2O plus NO, which is a gas, and you need to know these. You need to know these by heart. B reaction. If nitric acid is producing carbon dioxide, it must have a carbonate, and so that will give us 2NaNO3 plus H2O plus CO2 up arrow. Let us look at our C reaction. Nitric acid to nitrogen dioxide. So let us take copper again, but in this case we will take nitric acid, which will be concentrated, and we will get CuNO3 twice plus H2O plus NO2, and the balance reaction is we come to D. Nitric acid to sulfuric acid. So sulfur will be added to concentrated nitric acid, and it will give us, on heating, H2SO4 plus 2 H2O plus 6 NO2 up arrow. Your E reaction, nitric acid to hydrogen. So nitric acid releases hydrogen only with Mn and Mg with cold, very dilute, 1% dilution, and there we will have Mg NO3 twice plus hydrogen gas. Now these are some more conversions like this: A, B, C, D, E, F, G, like so. I think you can try these on your own. Let us look at the next one. Again, metal plus chlorine gives reddish brown scales, which means a chloride has been formed. And when it is treated with sodium hydroxide, you get reddish brown precipitate. This is the major clue. So what we have got over here is reddish brown precipitate is, and so with chlorine, the metal which must have been iron, has become FeCl3, and then it has become this. So identify A, B and C. So A is iron metal, B is iron 3 chloride, C is ferric hydroxide. What are the conditions for the reaction metal A and chlorine to get B? It should be dry chlorine gas, and it should be heated. Equation as well. So we'll have metal plus chlorine, 2Fe plus 3Cl2 gives 2FeCl3 is the reaction. Write the balanced chemical equation when C is heated strongly. C is FeOH thrice. Now when it is heated, it will become Fe2O3. So we'll have to put 2 in front of this, and that will give us 3H2O, and it is balanced. Write the balance equations for this sodium thiosulfate. I think you can do this. Aluminium reacts with conch solution of sodium hydroxide. Look at some more conversions here. Sodium thiosulfate is reacted with dilute hydrochloric acid. We've already done this reaction. You can do this on your own. Aluminium reacts with conch solution of sodium hydroxide. Now here as well, we have 2Al plus 2NaOH plus 2H2O gives 2NaAlO2 plus 3H2, which is a gas. Zinc oxide reacts with potassium hydroxide, exactly the same. ZNO plus NaOH will give us Na2ZnO2, and plus it will be H2O. Sulfur is treated with conch nitric acid. So S plus 6HNO3 conch. You know this reaction, we've repeated this. Red lead is warmed with conch hydrochloric acid. Red lead is Pb3O4, and plus it will be 8 red lead is warmed with conch hydrochloric acid. So we have Pb3O4 plus 8 HCl concentrated. On heating gives 3 PbCl2 plus 4 H2O plus Cl2, which is a gas. Another one of the popular questions of same kind is making use of the following substances only. Write the balanced equations for obtaining these. And this is the list over here, these ones. The first one we have to produce is hydrogen. So we will hydrogen, and here we have this acid. So we will need an active metal. Let's take zinc. So zinc plus H2SO4 dilute will give us ZnSO4 plus H2. Second one, if I want carbon dioxide, I need to take Na2CO3, which is sodium carbonate, and plus I'll take acid, because the acid will have a reaction like so, and that will give us H2O plus CO2, which is a gas. So we got Now hydrogen sulfide, so we need to take a sulfide. Can you see this? So I have Na2S plus again H2SO4, which is dilute, and that will give us Na2SO4 plus H2 will take this S, H2S, which is also a gas. Then we have the fourth one, which is I need sulfur. Now sulfur, so I will have to take sodium sulfide, and now I'll have to take H2SO4. We have to take sulfur dioxide to prepare, so I must take sulfite, so Na2SO3 plus H2SO4 dilute, and that will give me again Na2SO4 plus I'll have H2O plus SO2, which is a gas. And now we come to the fifth one, which is zinc carbonate. Now zinc carbonate, it's a precipitate. This is insoluble, so I will need zinc compound, a salt of zinc which is soluble. So now zinc will have to be reacted with the acid that is given as sulfuric acid. So you will have the first reaction being Zn plus H2SO4 dilute, which gives ZnSO4 plus H2, and the second reaction will be ZnSO4, which is an aqueous solution, will have to be reacted with sodium carbonate to bring this carbonate, which is again a soluble sodium carbonate, and that will give us Na2SO4, and plus it will be ZnCO3, which is insoluble substance. Let's come to another question. Write the observation and complete the balanced equation. Aqueous solution of ferrous sulfate is made to react with ammonium hydroxide. Now ferrous hydroxide, it will be dirty green. Precipitate of FeOH twice, which is insoluble in excess of ammonium hydroxide solution. The reaction being FeSO4 plus 2NH4OH gives us FeOH twice, which is a precipitate, plus NH4 twice SO4. Ammonia gas is passed through heated copper oxide. Now here copper oxide is black. Copper oxide turns to pinkish brown copper metal, and the reaction is 3Cu O plus 2NH3 on heating gives 3Cu plus 3H2O plus N2, which is a gas. A glass rod dipped in concentrated hydrochloric acid is introduced in a gas jar full of ammonia. Now, gas jar full of ammonia and we have hydrochloric acid, we will have dense white fumes of ammonium chloride formed. The reaction is very simple. We have NH3 plus HCl gives NH4Cl. The next type of question is where we have organic chemistry, IUPAC names and the functional groups. Now for that you have to take the longest chain, number the carbons, and now it is going to be, this is an aldehyde, 1, 2, 3, 4 carbons, so it is bute, and it is single bond, so butane and al, and the functional group is dash CHO, which is aldehydic group. Next one, here you will see this is the functional group, and so the longest chain 1, 2, 3, 4, it is bute, and the second carbon, this is first carbon, this is second carbon has got methyl, so it is 2 methyl butanoic acid, and the functional group is dash COOH, which is carboxylic acid group. Now for the third one, this is the longest chain which has got 4 carbons, and here 1, 2, 3. So the second carbon has got OH group, so it is going to be, it is butanol, but it is 2-butanol, or you can write it as butane-2-ol, and the functional group is dash OH, which is hydroxyl group. We come to the next one, the longest chain 1, 2, 3, 1, 2, 3. You must count from the functional group. Now this is C double bond O single bond OH, so it's carboxylic acid, and it is 1, 2, 3 means prop, and the second one has got this, which is methyl group, so it is 2-methyl 1, 2, 3 prop, so propanoic acid, and the functional group is dash COOH, and that dash COOH means it is carboxylic acid group. Out here 1, 2, 3, this is prop again, and we have 2 chlorines here, so it will be counting like this, so the name will be 1, 2 dichloro-propane, and the functional group is chloro, which is dash Cl. The next one 1, 2, 3, 4, but the functional group is here. The functional group for this is this, and so we will have to take the chain which goes like this. So this is your first carbon, second carbon, third carbon and fourth carbon. And the second carbon has got methyl. So this is your 2-methyl. And 1, 2, 3, 4, so it is bute. So it is bute and single bond, so ane. So it is 2-methyl, 1, 2, 3, 4, so that is bute and butane dash 1 OH means all. And here the functional group is dash OH, which is hydroxyl group. The next one, if you look at the longest chain will be like so. So it will be 1, 2, 3, 4, 5. You can count like this, but the branch is here. So you have to start from the branch. So it will be not this way, but this way. 1, 2, 3, 4, and this will be 5. And so it will be 2-methyl, and here it will be 1, 2, 3, 4, 5. So it is pentane. And here the functional group is alkane, all single bond. Next one, straight chain has got 4 carbons and this is the branch, so it will be 1, 2, 3, 4. So there are 2 methyl groups, so 2, 2 dimethyl, 1, 2, 3, 4, so that is butane, and here again it is an alkane. This particular one, the longest chain, this bond has got cancelled here. This is the functional group, so it is an alcohol, 1, 2, 3, so it is prop, so it is propanol, and the first carbon, so it is 1 propanol, and it will be dash OH, which is hydroxyl group. Now the next type of question is give reasons. Solid ionic compounds are non-electrolyte. Here you have to say ionic compounds have strong force of attraction between the cation and anion, and the ions not being free, they will not be available for conducting electricity. These are the keywords. Iron 3 chloride is stored in airtight bottles. Iron 3 chloride is highly deliquescent, absorbs moisture, dissolves in it. These are the keywords. Carbon tetrachloride does not dissolve in water. Non-polar covalent compound, water polar covalent compound does not dissolve. Non-polar dissolves in non-polar. Sugar chars after some time when it comes in contact with concentrated sulfuric acid. Concentrated sulfuric acid is a dehydrating agent, removes the elements of water, that is H and O, in the ratio 2:1 from sugar, and only black mass of carbon remains. That's how it gets charred. The next one is where we have washing soda crystals suffer loss in mass when exposed to the atmosphere. The loss in mass must be because they are losing the water of crystallization. So it's an efflorescent substance. That is what is the answer. Copper, though a good conductor of electricity, is a non-electrolyte. This is a very popular one. Everybody must be knowing this already. Let's skip that. A coating of zinc protects iron from rusting. Remember, zinc is higher in the EC series compared to iron, so it will be more electropositive, forms cation more readily, and therefore prevents rusting of iron. A graphite anode is preferred to any other inert electrodes during electrolysis of fused lead bromide. Remember, bromide will have bromine vapors at anode being liberated, and they are corrosive in nature, and so even iron will be attacked, but graphite will not get affected. Iron 3 chloride is to be stored in airtight containers. This is a repeat, so we'll skip that. Give the answers in one word. This is again another type of question that is very, very popular. It will be there in section 1, sometimes in section 2 as well. Property of carbon to form long chains is catenation. Number of atoms present in one molecule of an element is atomicity. Covering an inferior metal by superior metal by the process of electrolysis is electroplating. Property of losing water of crystallization to hot air is efflorescence. Reaction of methane with chlorine in presence of diffuse sunlight, and that is your substitution reaction. Then we have the empirical formula and the molecular formula over here. Let us come to the ninth type of question. This is on mole concept and stoichiometry. We have a gas cylinder filled with hydrogen holds 5 grams of gas. The same cylinder can hold 85 grams of gas under the same temperature and pressure. Find the vapor density of gas X and its molecular weight. Now, as you can see, the mass is given of the same volume, and so we are using the formula for vapor density. Vapor density, mass of certain volume of gas upon mass of equal volume of H2. So mass of certain volume of gas, gas X has volume how much? 85 grams, and equal volume is hydrogen, that is having mass 5 grams. So you will see gram gets cancelled and you will have 17 as the vapor density. The second part says its molecular weight is to be found out. Now, what is the relation between molecular weight and vapor density? Molecular weight is equal to 2 into vapor density. So that becomes 2 into 17, which is 34, and that's our answer. Let's come to another question. A hydrocarbon has 14.3% of hydrogen, and its empirical and molecular formula is to be found out. We have been given the atomic weight of carbon and hydrogen, and RMM, that is relative molecular mass of hydrocarbon, that is given as 28. Now when we have like this percentage composition, we have to find the empirical formula. We will make the columns like so. The first column is elements, so we write carbon, hydrogen. Percentages we write. Now hydrogen is 14.3, so we subtract 14.3 from 100, and that will give us 85.7% as the percentage of carbon. Atomic weights are 12 and 1, and relative number of atoms, we take the percentage and divide by atomic weight in both cases. And now here you'll see 12 sevens 84, 1 remains, so it will go 12 ones and then it will be 5 times, so 7.15. And here 14.3 upon 1 is 14.3. And now we will take the simple ratio. So we divide both these numbers with the least number, that is 7.15. And you will see here it goes once. And here you will see 7 2s 14 and 15 2s 30. If you look at this comparison, it is going twice. So our ratio is 1:2. that is C is to H is 1:2. So our empirical formula becomes CH2. The next step is to find empirical formula weight. So carbon is 12 plus H is 1, so 2H will be 2, and that gives us 14 as the empirical formula weight. Our next step is to write our molecular weight. We have been given RMM, which is good enough, that is 28, and then we find N. N is molecular formula weight or RMM upon empirical formula weight. That will be 28 upon 14, which is 2. And so we will have now molecular formula will be twice empirical formula, N into empirical formula. So 2 into bracket CH2, and that becomes C2H4, which is our answer 1. Now we have been asked name the compound, and that is ethene, because this is CnH2n, and then we have to write its structural formula. So ethene is your C double bond C. So we have shown that double bond. Carbon has 4 valencies, so we'll show that valency, and here HH per valency, and that's our answer 3. Now we come to the next question. The equation for the burning of octane is 2C8H18 plus 25O2 gives 16CO2 plus 18H2O. First subpart, how many moles of carbon dioxide are produced? So we are asked the moles of carbon dioxide when 1 mole of octane burns. Now there are 2 moles of octane giving you 16 moles of CO2. So 1 mole will give you 8. Let us come to the second one. What volume at STP is occupied by the number of moles determined by you in the above question? Now in the above question we got 8 moles. So we have to find out the volume at STP of those 8 moles. The third subpart, if the RMM of carbon dioxide is 44, what is the mass of carbon dioxide produced by burning 2 moles of octane? That means as in the reaction, you have to find the mass of this. What is the empirical formula of octane? Now let us see the solution. We write the reaction. We have been given the reaction with 2 moles of octane giving us 16 moles of CO2. Our first question is, if it is 1 mole of octane, then how many moles of CO2? So we'll make for the first part 2 columns, number of moles of octane and number of moles of CO2. In the equation we have 2 moles, we write here 2 moles. Here we have 16, so we write here 16. And if it is 1 mole, then how much? And that's how we get our first answer. This was relatively simple. Now directly I am coming to the third subpart. The second subpart was to find the volume of CO2. Now let us come to the third one. The third one is where RMM of CO2 is given. They are asking us to find the mass of CO2 produced by burning 2 moles of octane. Now burning 2 moles of octane, we have got 16 moles of CO2. So mass of 16 moles of CO2 will be 16 multiplied by RMM, because 1 mole will have 44 grams as the mass. So 16 will have 16 into 44, and we multiply it and we write the answer. That is our answer 3. Now fourth subpart is where RMM of octane has been given as 114 and volume of oxygen required they are asking. So we connect with octane and the oxygen. If we have 2 moles of it, we are getting 25 moles of oxygen here. So we have to now look at volume of O2 required. So our second column will be volume of oxygen at STP. The first one connected with RMM means mass of octane. Now octane is here 2 moles. So it will be 2 into 114 which has been supplied. See, when you cancel it like this so that it doesn't interfere with the reading of your examiner. So corresponding to 2 moles, that is 2 into 114 grams of octane, the volume of oxygen is going to be 25 times the molar volume, that is 22.4 liters at STP. So if it is 22.8 grams of octane, which is given in our question, then volume of oxygen will be how much? So we put X over here and then we write X equal to, take the numbers across, multiply them, and I have removed the decimal point. As you can see, 22.8 I have written like so, and then you will be dividing now with 2 into 114, so that comes here. Now look at our 114, this I have cancelled, and so it is 114 here, and 114 goes twice into 28, and look at this, we have 2 ones and 2 fives, 5 goes 5 times, this 5 goes here in 10 twice, this 2 goes into 2 for 112 times, so we have 112 liters at STP, and that is our answer 4, as that is the volume of oxygen required. The last part of that question was, what is the empirical formula of octane? You can do this on your own. You can remove the common factor as you write your ratio and you will get your answer. Let us come to another question where we have the percentages are given and we have to find the empirical formula and the molecular formula. Vapor density also is supplied. So we write the compositions of carbon, hydrogen and oxygen as they were given in the question. Vapor density is given as 44. We have to find the empirical and the molecular formula. We make the table as I showed you earlier. First is element percentage, then we have atomic weight, then we have relative number of atoms, and then we have simple ratio. We write the percentages, we write the atomic weights, and relative number of atoms is the percentage divided by atomic weight. Here also, percentage divided by atomic weight. Percentage divided by atomic weight. Now here the calculations are pretty simple, but I have shown the columns here also. Now it's important that you show your working side by side simultaneously so that it's easier for you to recheck as well. So 54.55 is being divided by 12, and you can see it is 4.52, so I have written 4.52. 9.01 divided by 1 remains the same. Then oxygen 36.26 is divided by, and you get 2.26. Now least of these is this, so we divide each one of these by this, so it becomes 4.52 upon 2.26, which is equal to 2. You can see this, 26 2 is 52. Here it will go 4 times. If you multiply this by 4, you get a number which is very close to this. We come to 2.26 divided by 2.26, that gives you 1. And that simple ratio is C is to H is to O. And so the empirical formula becomes C2H4O. Empirical formula weight, we will take C 2 into 12, H 4 into 1, oxygen 1 into 16. So now let us come to our solution. So we have 24 plus 4 plus 16, which is equal to 44. And then we have molecular weight, vapor density has been supplied as 44. And our formula for vapor density and molecular formula is molecular weight equal to 2 into vapor density, that is 2 into 44. Now N is molecular weight upon empirical formula weight, which is 2 into 44. This divided by 44. 44 gets cancelled and you will have N as 2. Then we have molecular formula equal to N into empirical formula. So I've written the empirical formula 2 into C2H4O, and that gives us C4H8O2, and that is our answer. Let's come to another question. A gas cylinder contains 24 into 10 to the power 24 molecules. Avogadro's number is 6 into 10 to the power 23, and RMM of nitrogen is given as 14. Calculate the mass of nitrogen gas in the cylinder and the volume of oxygen at STP. For solving the question, let us write the number of molecules of nitrogen that was given as 24 into 10 to the power 24, and Avogadro's number was supplied as, and RMM of nitrogen was given as. So now first part was find the mass of nitrogen, and because we have to find the mass, we must find the GMM of nitrogen. Nitrogen molecule has 2 atoms, so 2 into 14 gives us 28 gram. Then we make the 2 columns, number of molecules which is supplied and the mass of nitrogen which is to be found out. So if the number of molecules 6 into 10 to the power 23 is for 1 mole, mass of 1 mole is 28 grams, so this becomes our first line, and therefore 24 into 10 to the power 24 gives you X, which we have to find. Numbers across multiply like so. This we divide like so, and calculations you will see 6 ones and 6 goes 4 times. Then 10 to the power 23. So 23 will go and only 10 to the power 23, the whole thing will go, and you will have only 10 remaining here. And so you will have 28 into 4. So you have 28 into 4 is 112, and this 0. So that will give you 1120 gram, and that is our answer 1. The second part is the volume of nitrogen at STP. So we go with what we are already supplied with the information, number of molecules, and we have to find the volume at STP. So we will take the molar data, that is 6 into 10 to the power 23. Then the volume at STP of gas is 22.4 liters. So if it is 24 into 10 to the power 24, then it will be X. So let us take the numbers across. 24 into 10 to the power 24 multiplied by 224 upon 10, removing the decimal, and divided by this number, that is 6 into 10 to the power 23. Now 10 to the power 23 goes, and here only 110 remains. That 0 cancels with this 0, and now we have 4 6 1 6 4s, and 4 multiplies here. So 4 4 16 1 4 2s 8 1 9 4 2s 8 896 liters at STP, and that is our answer. Let us come to another question. Commercial sodium hydroxide weighing 30 grams has some sodium chloride in it. The mixture on dissolving with water in subsequent treatment with excess of silver nitrate solution, it forms a precipitate weighing 14.3 grams. What is the percentage of sodium chloride in the commercial sample? And the reaction has been supplied, RMMs have been supplied. So I have written the mass of the commercial NaOH containing NaCl is given as 30 grams. Percentage of NaCl in the sample is to be found out. I have written the reaction. I have written the RMMs. This is 58 gram. This is 143 gram. And in order to find the percentage of NaCl, I need to first find the mass of NaCl. So I have put over here X. And the statement, let the mass of NaCl in the sample be X gram. And mass of AgCl formed, here it is given as 14.3. It's been supplied. So now we compare with what we know over here to what we have to find out. So our two quantities will be mass of AgCl and mass of NaCl. Mass of AgCl, if it is 143, mass of NaCl is 58. And so if it is 14.3 gram, then X, numbers across have been multiplied. This 143 upon 10 it has become, and then we divide by the third number, that is this 143 gets cancelled, 58 upon 10 gives you 5.8 gram. Now in order to find the percentage of NaCl, I need the mass of NaCl, which we found out here, and then mass of NaCl upon the total mass of the sample multiplied by 100 gives you the percentage. So 5.8 upon total mass of the sample was given to us as 30 gram multiplied by 100%. 0 gets cancelled. This 0 shifts the decimal here. 58 upon 3. 3 ones 3. Remain 2. 3 nines 27. 1 remains, so 1/3 means 0.33%. And that is our answer. We come to the 10th type of question, which is an important question for your ICSE boards. Give one test to distinguish between zinc nitrate and calcium nitrate. Then we have second one, iron chloride and copper chloride, zinc nitrate solution and lead nitrate solution, and copper 2 oxide and manganese 4 oxide. Now out here I have just solved this one. What we have to understand is that both of them are nitrates. So what is different is zinc and calcium. So I should take the reagent which will help me to distinguish between the two. For our solution, we will make 3 columns like so. The first one will be for the test. Second one will be for the first reagent that we have to distinguish zinc nitrate solution. The second one is calcium nitrate solution, we write here. And the one that will help us to distinguish between zinc and calcium, that will be our NH4OH solution, that is ammonium hydroxide. So we add ammonium hydroxide solution to each solution, first little and then in excess. Now this step must be mentioned. Zinc with Zn2 plus will give gelatinous white precipitate, which is soluble in excess of ammonium hydroxide, and then we say that zinc 2 plus is present, which will give you zinc nitrate as the compound, the salt present. Whereas in calcium nitrate, there will be no precipitate because calcium cannot be precipitated out because of NH4OH. This is a weak alkali. Then calcium nitrate is present. This is the way we present our work. Let us see the remaining ones. For the remaining ones, I'm not going to show you how to write, but I'll just discuss this with you and you can write on your own actually. Now you have to see what is different. So iron chloride and copper chloride. This one is iron as a cation separate and this is copper. So we will add either NaOH or NH4OH solution. If we add NaOH solution to each, iron chloride, this will be iron 2. It will give you dirty green precipitate which is insoluble in excess, whereas copper will give you blue, pale blue precipitate actually, that will be insoluble in excess when we add NaOH. Now zinc nitrate and lead nitrate. What is different? Zinc and lead. Now both of these give white precipitate which is soluble in excess if it is sodium hydroxide. But if it is ammonium hydroxide, this zinc will give soluble in excess white precipitate and lead will give us the white precipitate which will be insoluble. So we'll choose to take NH4OH solution first in little and then in excess, like how I showed you the format. And then we write for zinc the same description. If gelatinous white precipitate of zinc hydroxide which is soluble in excess, then Zn2 plus present, therefore zinc nitrate solution present. And for lead, what we will write? We will say if chalky white precipitate which is insoluble in excess of NH4OH, then Pb2 plus is present, therefore lead nitrate solution present. When it comes to copper 2 oxide and manganese 4 oxide, both of them are black powders. But what we will do is add concentrated HCl to each and heat. Now this will give you blue solution but no chlorine. That means no greenish yellow gas. But for manganese oxide, on heating, this will evolve greenish yellow chlorine gas which will turn moist blue litmus red and then bleach it to colorless. Now let us come to some of the miscellaneous questions. These are based on analytical chemistry. X, Y, Z are 3 crystalline solids. Now crystalline solids means mostly they will be nitrates, are soluble in water and have experimental observation and copy and complete the corresponding inferences from 1 to 4. The first observation says that a reddish brown gas is obtained when they are separately warmed with conc H2SO4. Now, concentrated H2SO4 will liberate reddish brown gas, which is nitrogen dioxide, along with copper turnings only when there is nitrate present. So the common anion is going to be nitrate, which is going to be NO3 1 minus ion. Second one, when X is heated, it melts and gives off only one gas which relights the glowing splint, which means the gas is oxygen. Now, which nitrate will liberate only oxygen? Either potassium or sodium. So, cation is either Na1 plus, you will write into bracket sodium, and K1 plus. We have to write into bracket the word potassium ion as well. Let us come to the third one. The action of heat on Y produces reddish brown gas, which means NO2, and a yellow residue which fuses with the glass test tube, which means it is PbO that has stuck to the glass. And so the metal ion is going to be lead. And that lead will be Pb2 plus ion. So let's come to the fourth subpart. When Z is heated, it leaves no residue. When it leaves no residue, which means it will be ammonium nitrate. On warming Z with NaOH, so ammonium cation will react with this and it will be giving us ammonium hydroxide. It liberates a gas which turns moist red litmus blue, which means it is alkaline, so it is ammonia gas. And so Z contains ammonium ion. I'm just writing NH41 plus. You have to write it in words, ammonium as well. Write the equation for the action of heat on Y. Now, action of heat on Y, NH4NO3 on heating gives us N2O, which is laughing gas, plus 2H2O. Let us come to the metallurgy question. During electrolysis of molten alumina, why are carbon anodes periodically replaced? Now here you have to mention about the oxygen that is liberated at the anode due to Al2O3 being dissociated and oxygen being discharged at the anode combines with the graphite rods, the carbon in it, and produces carbon monoxide and carbon dioxide, and it consumes the electrodes. We have to mention that. Why is the electrolytic mixture covered with coke and sawdust? Now, coke and sawdust will prevent the heat from escaping, so the heat will remain in the electrolytic bath, and also understand that it will prevent the oxygen from combining chemically with the graphite rods and consuming it. Write the balanced equation for the ionization of alumina and the reaction at cathode and anode. Now, alumina is Al2O3, which dissociates into 2Al3 plus 3O2 minus. This is the dissociation. And then at cathode, we will have 2Al3 plus migrating, and they will gain 6 electrons to form 2 aluminium atoms. At anode, we will have 3O2 minus. They will lose 6 electrons, and that will give us 3 oxygen, which in turn will give us 3O2. Answer the following with respect to ethyne. Name the reactants used in the laboratory preparation of ethyne. Now, this you must know by heart. It is calcium carbide and water. So hydrolysis of calcium carbide takes place. Write the balanced equation for the reaction. This all of you should know by heart. How is the gas collected? Now the gas has impurities which dissolve in water, so it will be collected by downward displacement of water. Mark the keywords. Now the next question. Again, this is of metallurgy, and aluminium is extracted from its chief ore bauxite. What is bauxite chemically? Chemically, it is hydrated aluminium oxide. State the reason for addition of caustic alkali. Why do we add that NaOH to bauxite during its purification? Means concentration which is Bayer's process. Now what do we have with NaOH? NaOH, we have aluminium oxide being amphoteric, will dissolve in NaOH alkali because this is amphoteric, it dissolves. And the impurities that are present in this, which are the impurities? They are SiO2 and Fe2O3. What happens to them? They are basic in nature, so they will not dissolve in NaOH and therefore they will be separated out. Now this is what the keywords should have. Write the balanced equation for the above reaction. So we have Al2O3 dot 2H2O plus 2NaOH with the temperature 150 degrees C. It will give us 2NaAlO2 plus 3H2O. During the electrolytic reduction of alumina, two other substances are added to it. Remember, cryolite and fluorspar. You have to write the names and give two reasons for their addition. Now this is again a learning up question. Prepare this well. Write the cathode and anode reaction in the above reduction. Now in the above reduction, remember we will have for cathode, it will be Al3 plus, will gain 3 electrons to give you 3Al, and anode will be where we have 2Al. At anode we will have aluminium taking part in the reaction, loses 3 electrons, and that will give you Al3 plus. We come to the next question where you have matched the following. Now here again, sodium hydrogen carbonate is an acid salt because of this hydrogen. So it's an acid salt, so this becomes C. Sugar solution. Now sugar solution is only molecules because it's a covalent compound, organic compound. So it has only molecules. That will be your D. Ammonium hydroxide. It's a weak alkali. So it will have both ions and molecules. So that will be your E. Sodium carbonate is a normal salt because there's no hydrogen here. Remember, that's the key word there. So that will be your normal salt. That is your A. Sodium hydroxide solution is a strong alkali. So it will be having only ions. The next question. Which feature of ammonia molecule leads to the formation of ammonium ion when ammonia is dissolved in water? It is that it has lone pair of electrons. Name the other ion formed when ammonia dissolves in water is hydroxyl, which will be OH1 minus will be formed there. Name one salt of ammonia which is used in fertilizers, that is ammonium phosphate. Dry cells is ammonium chloride. These are all objective questions. How does ammonia react with excess chlorine? Here they are asking you for reaction. So we say that it reacts with excess chlorine forming NCl3. So we shall write NH3 plus 3Cl2 will give us NCl3 plus 3HCl. The diagram shows the arrangement of laboratory preparation of an acid which stains skin yellow. Stains skin yellow means it is nitric acid. So look at the diagram here. This is preparation of nitric acid. They are asking you to find X, Y and Z. Now X is the solid, Y is the liquid. So for nitric acid we will take the solid as potassium nitrate. You have to spell it in words. Y will be your concentrated sulfuric acid, and Z that is formed over here, that is nitric acid. We'll spell it out. I'm just writing it in short to save on time. Write the balanced equation for the reaction between X and Y. So we have KNO3 plus H2SO4 concentrated with temperature less than 200 degrees C. It forms KHSO4 plus HNO3. What is the special feature of the apparatus? It is all glass apparatus including the stopper here or the cork. Why should the temperature of the reaction mixture not be allowed to rise above 200 degrees C? So now this is a very important reason. You have to learn it by heart, that it forms above 200 normal salt which sticks to the glass, wastes the fuel, bad conductor of heat. Also at higher temperature your nitric acid will decompose. All that you have to mention. Why is cold water poured over the receiving flask? Now receiving flask, the water is poured because nitric acid vapors are formed and they have to condense. So to condense the vapors of nitric acid. The action of heat on blue solid which is crystalline gives reddish brown gas Q. Reddish brown gas means it is nitrogen dioxide, which means it will have to give us nitrate as the anion, and blue crystalline means it will be copper 2 plus cation. And it gives another gas which relights the glowing splint and a black residue R. Now relights the glowing splint, which means it is oxygen that is liberated, and black residue R will be the CuO, which will be remaining as the residue. So identify P, Q and R. P is copper nitrate. Q is nitrogen dioxide. And R is copper 2 oxide. Write the equation for the action of heat on P, that is 2 CuNO3 twice. On heating gives 2 CuO plus 4 NO2 plus O2, both being gases. We show up arrow. We come to match the following. Now match the following. Let's look at our question. Graphite 44 grams, silver 22.4 liter, vapor density. Now let us look at graphite. Graphite is the inactive electrode, inert electrode, so that is one I'm keeping here. 44 gram is going to be mass. Where is mass? Molar mass of carbon dioxide. Yes, so that is your 2. Silver. Now silver, none of these match. So it will be active electrode, that is 3, third one here. And 22.4 liter is volume of 1 mole at STP of any gas. So water vapor is a gas, so that matches here. And vapor density is connected with the RMM. RMM is twice vapor density, so vapor density is half of it. Let us come to the next question. Two gases, ammonia and hydrogen chloride, which one is less dense? Means lighter. Lighter will be ammonia. Name the method of collection of this gas. It will be by downward displacement of air. Write the balanced equation for the reaction in which ammonia is oxidized by a metal oxide. Now ammonia is oxidized means ammonia is a reducing agent. So for our metal oxide you can take either CuO or PbO. I am taking CuO. So 2CuO plus 2NH3 on heating gives 3Cu plus 3H2O plus N2, which is a gas. Now gas which is not an oxygen, in which ammonia shows its reducing property, will be chlorine. So you will have NH3 plus Cl2, and I am taking excess of Cl2, and that gives us NCl3 plus 3HCl. Now next question is the last question that I have for you under the different questions. Here again, property of sulfuric acid, very important. You have to know all the properties of sulfuric acid and the reactions with the different substances. So they react these substances with sulfuric acid. They are saying write balanced equations for the reactions indicating clearly if the acid used is dilute or concentrated. Now for the sugar, it is dehydrating property. We use conc sulfuric acid. For sodium chloride, we will use conc sulfuric acid, and it will be less than 200 degrees C. And here it will be the property being it is a dibasic acid because it is going to form a normal salt as well as it can form the acid salt. With sulfur, it is going to oxidize sulfur. So you will have S plus 2H2SO4 and then you will get 3SO2 plus 2H2O. You have to know these reactions very well. Then we come to sodium bicarbonate. Here it will react with dilute sulfuric acid because the bicarbonate part over here, it is going to help us liberate carbon dioxide from this, and that is dilute acid property. These ones are very simple reactions. You have to know them by heart. So prepare yourselves well. All of you study well, do the important chapters. I've already put up the important chapters which you have to know absolutely thoroughly. Do prepare them absolutely thoroughly. All the best and thank you for watching.